Now we are going to look at increasing and decreasing functions. A function is increasing when it's got a positive gradient, it's going up, and it's decreasing when it's got a negative gradient, it's going down. The first question, find the values of x for which f of x is an increasing function. So where is it going up? Let's find the gradient. So the gradient function, if we've got the notation f of x, our gradient function, f dash x or f prime x. Let's find the gradient. Times by the power, take one off the power. So we're going to have 2 minus 2x. That's our gradient function. Where is it increasing? So it's increasing where 2 minus 2x is positive, where it's bigger than 0. Let's add 2x to both sides and half both sides. So it's increasing when x is less than 1. One for you to try. Give it a go. So this time f of x is 3x squared plus 2x minus 5. So f dash x is 6x plus 2. That's our gradient function. It's increasing when the gradient is positive. It's going up when it's got a positive gradient. So let's take 2 away from both sides and divide by 6. So negative 2 over 6 or 1/3. So it's increasing when x is bigger than minus 1/3. Find the values of x for which f of x is an increasing function again. So where is the gradient positive? So our gradient function. So to find the gradient function, we times by the power, take one off the power. So we've got 3x squared minus 4x minus 4. So we want to know where 3x squared minus 4x minus 4 is bigger than 0. Where is it positive? So we're solving a quadratic inequality. Our calculator will do it for us. But if we weren't using a calculator, I'll show you how to do it with a calculator in a second. We do a times c to factorize, which is negative 12. What multiplies to make a negative 12 and adds to give a negative 4. That's 2 and 6. It's plus 2 minus 6. And then we're going to factorize. What can I take out of the first two terms? They've both got x in them. X times 3x makes 3x squared. X times 2 is 2x. Negative 2 times 3x is negative 6x. And negative 2 times positive 2 is negative 4. So where is x minus 2 times 3x plus 2 bigger than 0? Let's have a quick sketch here. So it's equal to 0 when x is 2 and when x is negative 2/3. So negative 2/3 and 2, they're the points where it's equal to 0. That's here and here. Where is it bigger than 0? So it's bigger than 0 where it's above the x-axis. So it's when it's less than, so this side, when x is less than negative 2/3, and when x is bigger than 2. On the calculator, we'll menu inequality, polynomial degree 2, it's a quadratic, and it's in the form ax squared plus bx plus c is bigger than 0. We've got a is 3, b is negative 4, c is also negative 4, and we're told x is less than negative 2 over 3, or x is bigger than 2, as we have here. One for you to try. Give it a go. So firstly, we're finding our gradient function. So times by the power, take 1 off the power. We want to know where it's increasing. So where it's bigger than 0. And I'm going to use the calculator. So A is 3, B is 8, C is -3. So x is less than -3, and x is bigger than 1/3. X is less than -3, and x is bigger than 1/3. Find the values of x for which f of x is a decreasing function. That means it's going down. It's got a negative gradient. So the gradient function, so 6 has got no gradient. Negative x has got a gradient of -1, and negative x squared times by the power, take 1 off the power. So where is it decreasing? It's decreasing where the gradient is negative, less than 0. So let's add 2x to both sides and half both sides. So x is bigger than -1/2. It's a decreasing function when x is bigger than -1/2. One for you to try. So our gradient function is 2x minus 4. We want to know where it's decreasing, where 2x minus 4 is negative, less than 0. So plus 4, half both sides. It's decreasing when x is less than 2. This question says show the function f of x equals x cubed minus 6x squared plus 14x minus 5 is increasing for all values of x. So if it's increasing for all values of x, its gradient is always positive. So we can find the gradient function. So we times by the power, take 1 off the power. So we've got 3x squared minus 12x plus 14. So if it's increasing for all values of x, that means 3x squared minus 12x plus 14 must always be positive. How can we show it's always positive? So we can complete the square and find the minimum point. That would be one method. And the minimum point will be positive. So it's a positive quadratic. And it's going to have a minimum point above the x-axis. It must always be above the x-axis. Otherwise, it would be negative. So if we find the minimum point and it's above the x-axis, that means it's always positive, because we know it's this shape because it's a quadratic, a positive quadratic. The same applies to we can find the discriminant. So the discriminant would tell us it never crosses the x-axis, and because it's a positive quadratic, that means it's always above the x-axis. So either one of those methods would be fine. So let's complete the square. So 3x squared minus 12x plus 14. I'm going to factorize out 3 out of the first two terms. I'll leave the 14 by itself. Then I'm going to complete the square on the x squared minus 4x. So half -4 is -2. Take away 2 squared, which is 4. So we have, expanding this bracket, 3 times x minus 2 squared minus 12 plus 14. So 3 times x minus 2 squared plus 2. So the minimum point is what makes the bracket 0, which is 2. And what's left, if that was 0, 2 would be left. So the minimum point is 2, 2. Therefore, it's always positive. So if the gradient is always positive, it is increasing. One for you to try. Give it a go. So we need to show it's increasing for all values of x. So let's find the gradient function, which is 6x squared plus 3. How can we show it's always positive? This one is actually a lot simpler. X squared is always positive. Because we're squaring it. Whatever number we put in, we square. Or it's always, it could be 0. X squared is always positive. So 6x squared plus 3. If we times a positive by 6, and then add 3, therefore, always positive. So if we times a positive number by 6, it's still positive. So positive times a positive is going to be positive. And then positive number plus 3 is positive. Or if we had 0 plus 3, it would also be positive. So therefore, it's increasing. For all values of x.